Hello, everyone. Good afternoon. Almost to the end here, right? 11 o'clock tonight, right? No, that's something else. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. This presentation, as well as a sample, will be on my GitHub at github.com/jbogard. And you can find me a blog about this and other topics at jimmybogard.com. And for my day job, I do a lot of this kind of stuff at a consultant company out of Texas called HudSpring. So me personally, I've actually been doing CI and CD for databases for quite a long time, probably like 15, 16 years now or so. So a lot of this is going to be some war stories and lessons learned about doing these kinds of activities over all the different kinds of ways you can possibly do it over the years. And one of the very first lessons I learned when trying to get started with CI and CD for databases was to be kind to your DBAs. Because their company prefers their data to your code. Like if they lost your code, they wouldn't care, but if they lost the data, they'd be really, really upset. So be kind to your DBAs. So if I look at just kind of normal CI/CD processes, it's like the typical kind of CI/CD processes are pretty simple. It basically starts out with a developer who wants to write some code. The developer makes some change to some code and pushes it up to GitHub. And then after they push it up to GitHub, then something takes that code and performs some kind of build around it, right? And then after the build, you produce some kind of artifact, and the artifact gets pushed out again to some kind of CD tool that finally is going to push your code out into production. Now I think I'm supposed to change the logos from Azure Pipelines to GitHub Actions, but I didn't quite get that done in time. So this is actually a pretty straightforward thing to do. Like all the tooling, all the stuff makes this sort of thing really, really easy. In fact, like this entire pipeline, you can basically do all from inside something like Visual Studio. You can right-click, start doing stuff, and it'll automate this entire pipeline for you. And the reason why this is super easy for us to do is because applications are ideally stateless. That is, it is really easy for us to create and destroy them because we have to worry about the application holding on to any kind of state. But databases aren't. Like databases are, by their nature, stateful, right? That's where we put our information. So that means that it's much, much easier for us to screw that up because it's sitting there waiting for us to screw it up over there. It also means that data screw-ups are much, much harder to recover from because we may not have an ability to rewind time and go back in time. And I've had this happen before where I screwed up something in data in production, and then we had to go through that whole recovery process and try to get our backups to put state back to where it used to be. And it's just a very painful process. Whereas something like I screwed up an application or had a bug, I can fix it pretty quickly and get it out there and not really worry about what is going on at that point in time. I do notice that you won't really get fired for killing an application, but you will get fired for killing a database. Ask me how I know. Okay, so there's a lot more risk inherent with changing a database over changing an application because of the stateful nature. And a lot of companies I work with treat that risk as a danger, which means then we just won't change our database at all because any kind of change has all these sort of downstream implications. But if we want our database to be able to grow with a business and be able to evolve with a business, then we need to be able to change our database over time. And we want to have the same rigor applied to the processes we put in changing and deploying our applications over time to our database as well. We don't want to be paralyzed by fear and just say we're not going to throw up our hands and just not do anything. And so we want to have some kind of continuous integration and delivery process for our databases. Now, a lot of customers I work with who have the database, and sometimes it's even called the database, that sits in the middle of their enterprise, they have some really arcane change management processes where it has to go through 17 different levels of approvals, and then at the end you find out it's actually just one DBA running the script in production. But we don't want to do that, right? We don't want to have some mistake make the local news because we did something wrong. And you've probably seen this sometimes, right? Besides all the security holes that get found out and published about, I do every once in a while find some news article that's someone had access to production database and accidentally deleted the entire database. That still happens these days. And that happens because we're allowing humans to have access to run these queries. But we don't want to do that. We don't want to have a human involved in this process that could potentially screw things up for everybody. So we need a way to be able to safely automate changes to our database and allow that automation strategy to be able to handle any kind of situation we throw at it. Now I see two main approaches. One I vastly prefer and one that other people prefer for some reason. And those are desired state configuration, or DSC, and migrations. There's a lot of tools out there for desired state configuration, or DSC. One of the more popular ones in the Microsoft world is the database projects inside of Visual Studio. So you say right-click, create database project. Another very popular one is from RedGate, which is SQL compare. And the general idea behind desired state configuration is you have the state of where it is today, and you want it to get to the state that you want it to be. And so you picture out, here's the state I want it to be, and then some tool takes the diff between those two things and tries to figure out how to take your sketch or the existing state in production and then get that migrated from what you're telling it needs to be. So it needs to be able to be smart enough to be able to detect all the different changes that you've made, generate that script on the fly, and then be able to actually deploy it out there. Now, I've used those tools quite a bit. And they are very intelligent, smart tools, especially with the RedGate tools. They're just like absolutely amazing at what they can do. But the problem is that they introduce the possibility of failure because it can't detect every single kind of change that you could throw at it. We have situations where we're not just migrating schema, but we're also migrating data at the same time. And those kinds of tools just aren't smart enough or don't allow you to be able to say, okay, when you perform this kind of upgrade, also run these extra sort of things at the same time. And oftentimes, you won't know about the need to have a manual intervention until you actually try to run the tool. And so what I want to have happen, though, is a completely automated process for my deployment from end to end, application and database. And if there's some tool out there that we're using that introduces the possibility of needing manual intervention, well, then that kind of destroys the whole idea of continuous delivery, where I don't want to have any kind of human involved in that process. Now, there's probably a lot of you out there right now that have had success with these tools, and I'm not telling you not to use those, but anytime I have one of these tools that requires some kind of human intervention, we can't end up in a situation like this. We're like, okay, we got this existing thing that looks okay, but something went wrong, and now a human intervened, and here's what we end up with. So these tools aren't perfect for automating change detection and deployment. They're very, very, very good, but they're not perfect. And anything that's not perfect that could require human intervention is that possibility that something can get screwed up. I also find that the further the drift, the much more difficult these tools have to deal with it. And I've encountered situations where sometimes I'm deploying some system out to some remote environment, whether it's some remote location or something that's just really physically hard to get to. Like I've had systems where you have to get on a helicopter to be able to get out into the middle of the Gulf, to be able to take your thumb drive, stick it in, and perform the upgrade. And no one's been on that helicopter for 2 years, and so it's been a very long time since I've done any kind of upgrade. So in these kinds of automated tools that just kind of look at the before and after and try to figure it out on the fly, really fall down in cases where there could be a long time between my different deployments. So that's where database migrations come into play. And database migrations, instead of me having like a before and after picture and just figuring it out on the fly, instead I explicitly tell the tool, these are the steps I want you to perform to get your database from one version to the next. And very often what we'll do is include both of those things together. We'll include the data changes necessary to be able to change the application and whatever schema changes are necessary to be able to perform the migration. And those two things together then are part of that single source control commit. So I know in my source control at any point in time exactly what version my database is up against. So with this sort of system, it's not just like I can go back in time to see what the database looks like at here, but I can have a database that is many, many versions out of date, and the migrations are just applied one at a time until that database is finally at the version that I expect it to be. So for these migration tools to work, they need three things. They need a way to capture the changes that you want to perform, so you need somebody to describe the changes that you want to make on the database. They need a way to then apply those changes on the target database. And finally, they need to have some way to remember the changes that you've made to ensure that I don't accidentally make the same change twice or somehow get out of whack or out of date with the database I'm trying to affect. Now, database migrations have been around for quite a long time. I saw them like kind of simultaneously invented about the same time, but you see a lot of agile teams and processes really center around database migrations as the safest way to be able to take one database from one version to the next. Now, I'm a .NET developer, and we got migrations basically last, I guess, like everything else in the world. And some of the tools we see out there are pretty popular. One of them is Entity Framework Migrations. Entity Framework Migrations is a code-based migration tool that is, there's some kind of DSL or domain-specific language that I use to describe the change I want. In this case, it's just C# code. And a lot of the popular migration tools are like this, like Rails migrations for Ruby on Rails is a very similar kind of concept. Django has a similar kind of thing as well. The problem is, this is Entity Framework Migrations, right? And in order to get migrations approved, I have to talk to the database administrator. And DBAs love ORMs, right? And what they really love is like, hey, this tool I hate, there's another tool that's completely also hides the SQL that you're intending to run at the most important time, which is deployment. And so I've never actually gotten this kind of migration strategy ever approved by any kind of DBA. So this is not very DBA friendly. Now, one tool that is quite DBA friendly is a RedGate tool called SQL Change Automation. This is the third different name they've had for this tool, but it is a complete change automation migration utility. It allows you both to use the other kind of RedGate tools behind the scenes to figure out what schema changes have happened, and then does like your normal kind of migration process to be able to push it out into production. I've also used this in a couple clients as well. The big problem we saw with this, though, is it's not very wallet-friendly because they don't sell that thing by itself, and so every single person on the team needs that like the most expensive RedGate license. I mean, I love their tooling, but not everyone needs to pay like that much money for just to run migrations. And so although it's a very robust tool, I still have a very hard time with my clients trying to justify the entire SQL tool belt for every single person on the team. So with those two options, we much prefer something that is DBA friendly and also very easy to automate. And so the tool that I use is one called Roundhouse. Now Roundhouse, the reason why I like it is one, it's SQL centric. So the scripts that you write are SQL, not like some other DSL that gets translated in SQL. And so a lot of times we pair up DBAs with our developers to actually author those SQL scripts for us. I guess not really that hard to write DML statements, but they may be able to author them in a more efficient manner, or maybe they have some other things they have to do as part of the migration process. It has lots of .NET, lots of different database support, so we've used it for pretty much anything we can throw at, whether it's SQL Server, SQL Azure, Oracle, MySQL, Postgres. It just supports all those different kind of things. And because it's based on .NET Core, it's cross-platform, so I can run it as part of a Linux build, a Mac build, or a Windows build as well. So before we get too far into there, I want to take a step back and say there's one step of the process we want to make sure we still have as part of that, which is the very first part of this process, which is the developer experience. We want to make sure that they're involved in the entire continuous integration process. So what things do we need to put in place to enable them to have a robust continuous integration process? And the big thing we're trying to do here is allow the developer to safely make changes to the database, be able to run and test that locally before they actually push it out to a CI environment or out to production. And the big thing we want to do here is make sure that every single environment has its own logical database. One of the things I see developers often do is like they have like the database, which is the big monolithic database that everyone connects to, and they have like these weird replicated versions that everyone still tries to connect. And one of the problems I see with that approach is it's very hard to make sure that you don't accidentally overwrite someone else's changes. So one of the things I try to do is to make sure that every single developer has their own individual local dev database and a local test database. And by ensuring that we have isolated databases per individual developer, we make sure that the developer can make those changes in isolation before they even commit the code, before it actually goes out the door. So I want to show a quick demo of this just to see what it looks like to have a local database running with my individual developer. So let me go ahead and stop and switch over to Visual Studio. Okay, so What I've got here is just an application, but this application has an actual database behind the scenes. So we can run it, we can see it's got all these like actual models behind the scenes. And what I want to do is to make some kind of change to this application. So in this case, it's like if I want to make a simple change, something like just adding a field to the screen, I want to have something that actually means that I need to have some kind of database change along with that as well. Okay, so probably the easiest thing to do is just add some field to one of these items. So what I'd like to do is take one of the models and just add some property to here. What I want to do is find out how easy or difficult it is for me to just add some field to something that gets persisted, and then all the different places that need to happen as part of that. So I've got here just, this is just one of the Microsoft sample applications that I borrow because it's easier for me to just use what's already there. And I'll do something like, let's add something like pet name to this property, or to this class. So that's not going to be sufficient for me to have this application actually run, right? We have to still do things like add fields to the screens. So let's do that. On the page where I see all the list of students, I'll go add their pet name. Now I'll see it on the screen. And I'll need to add it to the list of results on the screen as well. So we'll go ahead and have pet name there. And now I can see the list of pets for this individual person. So if I ran this, though, right now, the application still wouldn't work because the application doesn't know that I've added this field, and that should be backed by something in the database as well. And so that's where migrations come into play. So the tool that I'm using, Roundhouse, allows me to author SQL scripts. And in this case, I'm just going to put them in a special folder called up. And up are all the scripts to upgrade the database from one version to the next. So I'm just going to duplicate my older one and cheat. And I'll call it something special. Add pet name to student. And as part of this, I'll include the DML to be able to describe how I should change this table. So in this case, I'll say I need to add pet name, and we'll just leave it as invarchar 100 because why not? Okay, now as part of this though, some people may not have a pet name already, and so I can decide at this point in time, do I also want to include any kind of data migrations to take an account that this information may not already exist? So as part of this, I can also do something like update person set pet name equal to, I don't know, Roger. Okay. So in addition to me actually changing the database schema, I'm also going to be filling in some information along with that process. So now I need to actually run these migrations. Now this is where it comes to like what makes most sense for the individual team. Now, some of the tools out there, like EF migrations, have PowerShell commandlets to do things. I've also seen some wonky things like the first time you run the application, it'll also try to migrate the database. But again, that's one of those things that my DBAs will not allow me to do, like migrate the database and make DML changes when I just run the thing. They want to be able to, I want to know exactly what's going to be run, and I want to have the ability to try that out myself before you just actually ship this out into production. All right, so to do so, I'm going to go ahead and run my local build. And as part of my local build, it's not only going to restore, compile, run, and run tests, it is also going to run my overall migrations. So we'll go ahead and let this go and watch it do the migrations thing. And while that's going, I'm going to pop open the actual script itself. So this is my build script. And one of the parts of my build script that I have as part of kind of doing the initial installation is installing this global tool for Roundhouse. So Roundhouse comes in a variety of different formats, and one of the ways you can use it is with a .NET global tool. So this way I say go ahead and update, which also will install it if it's not there, this tool, .NET-Roundhouse. And then from there, I can use an RH command. Let me bump up the font a wee bit. There we go. In that roundhouse command, I'm telling it to migrate each individual database that I'm interested in. So the first one it's going to do is migrate my local dev database. So that's that initial one right there. And I tell it the folder in which to look for the actual migration scripts, which is this app data folder. And then finally, I tell it what to connect to. So I'm saying, go ahead and connect to MS local DB. That would be whatever you want it to be locally. And then for my test database, I do something a little bit different. My test database, I actually drop it and recreate it every single time. And the reason why I'm doing this is just to ensure that I don't have any inadvertent bugs that only show up in my scripts if I migrate versus do one from scratch. So this is just kind of a backdrop for me to make sure that I haven't screwed anything up with my script. Okay, it looks like my build succeeded. And if I scroll up just a little bit, we'll see down here, it's running those two scripts against my local database for the test one. If I scroll up a little bit more, we'll see that it actually skipped the previous script that had already run, and it is running the second one that is actually against, that is new and I just created right here. So, behind the scenes, it's like the stupidest thing that could possibly work, but it has some more intelligence as part of it. So one of the things you can run into is a developer changing a script, which is a bad idea. So if I went over here and say, actually, you know what, I didn't like Roger. We want to have like, no pet, sorry. Right? Like, oh, we made a mistake with our script. Let's go ahead and change that. If I were to run this again, we're actually going to get an error because I've changed a script that should only run one time. That's something that migration utilities need to take into account is if migration scripts are only able to run in one direction, if there's something that someone changed as part of that script, then I don't know what to do, and it's just going to go ahead and blow up and say, you've done something to change the script, and now I can't tell what I'm supposed to do, and you need to go ahead and fix that. And the way it does this is pretty straightforward. As part of running the migrations, again, it's like the stupidest thing that could possibly work. What it'll do is every single script that it runs, it just has another database table that records all the scripts that you've created. And so as part of that, not just including the script name, is a hash of the file itself. So if you change that file and screw it up, the hash changes, and that's how it detects that you've screwed something up, and now you need to blow up and fix it. So let's fix that. Let's go back to where we were, Roger. And everything should work again, hopefully. Now, one of the things we wanted to do as part of local continuous integration were tests as well. So I wanted to just show one quick test to show how you can still use a local test database to make sure that everything in my application runs successfully. So as part of this one, we've got some tests to edit student information. I won't go through the whole thing, but one of the things I did want to highlight, as part of running this test, there's a lot of different ways I see folks try to run integration tests to make sure that my application will actually run successfully in production. One of the things that I like to do, though, is to ensure that the integration test matches as much as possible how the user actually interacts with this application in production. So instead of doing things like rolling back transactions or weird things like that, this integration test will connect to an actual live database. It will perform a series of actions, and each one of these actions like here and here, those are actually full round-trip transactions to ensure that my integration test matches as much as possible what we'd see in production with a real user using this application. So by the time my tests succeed, then I should have the greatest amount of confidence that my application is successful because I've made the change locally, I've got a local test database, it runs against it as if it would be in production, and then the build is green. Okay, so I'm going to go ahead and commit these changes. Favorite pet name. Oh, we didn't actually run the application. Let's do that. Let's run this and see if we can actually see the pet names show up here. Now, I think I was supposed to actually write a test that fails and do the whole TDD dance, but I didn't really feel like doing that. So we're just going to go, we'll just do it live here. Whatever. So I filled it with some dummy data. So if I go to the list of students, we should see a new column show up where their pet name is over there, name of Roger. I did forget to put the header up there, but I can fix that later. All right, so let's go ahead and push those changes up and talk about the next step in the process. So I've made my changes. Everything looks good locally. I authored my migration script. I've pushed up the changes. Well, the next step is going to be my build step, to build my changes and run those changes and those tests against, again, some kind of local database. Now, this is the kind of difficult part, I find, and it really depends on what my application is actually doing. So in some cases where I'm in a greenfield application, it's relatively easy for me to build out a kind of clean local test database in my CI environment. But that's not always the case. In some cases, we have some kind of shared test database that's used across all of my test runs, because maybe it's filled with some production-like data that I have to run against to ensure that my system runs against like kind of real-world data. So that part kind of depends, but I do find that most of the CI tools out there do have the ability to run some kind of pre-built image that has databases on there that you can run against. All right, so let's see how that works. And again, I haven't switched this over to GitHub Actions like I guess I was supposed to, so this is still just running against Azure pipelines. So let's go ahead and stop that. Now I'm going to switch over to Azure pipelines. Okay, hopefully GitHub Actions will be faster than this, because it does take a little bit of time for my CI build to run. But I have to have some, like, what does my CI build need to actually look like between how it looks locally versus how it works in running in a CI tool. So what I like to do is try to make my local build as much as possible match what I would expect to see in the CI environment. So instead of my CI environment having all these different steps to perform, instead what I'll do is, let me go ahead and show the template for this. The build that it's going to run is actually going to be the exact same build script that I would run locally. That way I can make sure that if something goes wrong with my CI build, well, I'm running the exact same script locally, so it should be very easy to debug any kind of differences or problems I may run into. This is kind of a controversial topic. I don't really care that much one way or the other. Just I want to make sure that if something goes wrong, that I have some way to figure out how to fix it. Now, the only big difference is I need to have some way to connect to test databases when I run my script. And so I might have some extra step of like creating specific test database instances or connecting to something that I've already built out in that environment. All right, let's see if this thing actually finished. Nope, still going, of course. So that build script that we've got going is fairly straightforward. It's basically a bunch of .NET commands. It's just .NET clean, build, my database migrations, test, and then publish. Now, the last piece in this puzzle is going to be, how do I take the migration scripts that I've created and then be able to deploy them out into different environments? And so that's my last step in the process here. But in my corporate environments, I don't just have one environment I'm deploying to. I typically have multiple environments. In this case, I've got like a dev and production one. And so there's not just like a final step of just push out the changes. I need to be able to automate the deployment out into each of these individual environments. So this basically I have to figure out, okay, deploying the application is relatively easy, but how do I deploy the database migration changes? How do I deploy and run that tool against these different environments? So go ahead and show how we do that. So the first piece of the puzzle is, at the end of a build, there's going to be some kind of artifact created. So as part of that artifact, I can include the SQL change scripts as part of my overall deployment. And so in my application, what I've done is I just stuck my SQL scripts in this special app data folder. And I know that's a special folder because Azure App Services recognizes that as a special folder where it won't allow any kind of access to. So it seems like a safe place to go ahead and put my migration scripts. And then as part of the deployment in the build at the bottom here, whenever it publishes out the application, I'm going to copy over all the tools I need in order to actually deploy this system. So I've got this Roundhouse, the Roundhouse executable tool, and all of the scripts that I've included. So all those things then get copied out into the deployed folder. So when you publish the application, it's got both the scripts and the running application that it can run in the deployment. So let's see if that actually finished. Still, it should be finished pretty soon. Let's see. So the last one took 5 minutes, and this one is going on 5 minutes, so it should be done pretty soon. But let's go and look at the log output to see what we can see here. Oh, it did finish. All right. So yeah, as part of the build, we can see down here, somewhere down here, it should see, there's the tool that's running our migrations against MS SQL Local DB. So again, this matches almost exactly what we have in our local environment is going to be in our CI environment as well. Again, anything I can eliminate between differences in those environments just ensures that I can catch those failures before I even commit or push the code out. Okay, the next part is going to be actually pushing this code out in production. So I've got two applications running. I've got the dev. Let's see if it's actually released. So it's running the deployment in progress. And behind the scenes, what is this doing? Edit pipeline. It's triggering off the release, and it's going to automatically deploy out into my dev environment. But the dev environment is going to be two individual tasks for its deployment. The first one is going to be deploying the Azure App Service. That's just straightforward Azure App Service. But the second part is going to be migrating the database. And migrating the database is just going to be a PowerShell script that is going to run the Roundhouse tool. So the Roundhouse tool, I just use the same kinds of arguments that I would use in my local environment. I use here as well, with a slight change that I'm going to make sure that the connection string it's going to use to connect to the database is passed in via secret as opposed to hard-coded inside of here. So I won't show that because, well, then you'll be able to see my connection string, but it's there, trust me. That's being passed in right here. So as part of that, it's running the deployment of my application and running the migration, and everything succeeds. So if I refresh my dev site, we should see the version update at the bottom. And if I go to the list of students, version 50, then we should see, again, that Roger over there on the right. And if, of course, I want to now push this out into production, then I can go back up to this build, or the release, and approve it. And now it will actually get deployed into production. So in this case, I do have a manual approval process, but the actual deployment itself is 100% automated. So with this approach, this SQL-based approach, it ensures that the scripts that I'm running, I know exactly what they're going to run and exactly the effect it's going to have on my target system. And so that kind of approach just ensures that I have complete control over exactly how my system is going to get upgraded. Now that's just kind of like the basic migration stuff. But what happens when we kind of turn this up to 11 and really start to do things at a much more massive scale? Those kinds of scripts that we saw earlier, like just alter database, add a column, those kinds of things don't necessarily work very well once I have a large, important system in production. So first thing we may have to worry about is how do we ensure that if I need to run the script twice, that the results only happen once? How do I make sure my scripts are idempotent? Well, sometimes we can rely on the migration script to be inside of a transaction. So some databases support transactional DML. That is, if something goes wrong, it'll actually roll back the changes to your database. But not all the time. So Roundhouse does run every single script in a transaction, but there's some changes that you need to make that cannot be completely combined in one single transaction. And there's some cases like just something went wrong, I don't know why, and I just have to like fiddle with again and make it run again. So one of the things that we can do is do like a check if exists sort of query. That is, when I run the migration script, if it don't just blindly try to make changes, but actually check to see if that thing exists first before I actually affect the change. So here's an example of looking for a table that exists. And for this, you kind of have to dig into whatever the schema definitions and views could be for your individual database. So some things support this standard view of information schema, some don't. And what I want to do is just say, check to see if the database, in this case, the table already exists. And if it does exist, then just like, there's nothing to do. Don't actually run the migration. Otherwise, it doesn't exist, so let's do this. I can also look at the column information and say, well, the table exists, but I need to add a new column. So I can check the information schema column table. I'm going to do a similar kind of thing with a stored procedure. To say, check to see if the stored procedure exists, and if it doesn't exist, then go ahead and perform the migration. So looking at the different kinds of migrations that I run to, there's basically two kinds of changes I'm making to my database. There's ones where it actually affects the state in the database. So it's affecting, the DML I'm running is affecting components that actually have some state involved with it. Or it could be something that's completely stateless, that has no state involved in that change whatsoever. When I do stateful changes, though, I do want to ensure that my changes that I'm committing include both schema and the data migrations. So if I'm adding columns or things like that, then as part of that exact same script, I'll include whatever data migrations are going to be necessary along with it. And the idea is that if there's something that goes wrong, it's just that one commit that includes all the changes as part of it, as opposed to trying to split things up and manage them separately. Now what about stateless changes? These are a bit easier than stateful changes. Like with a stateless change or stateful change, like adding, refactoring database tables or adding columns, things like that, those are going to have a pretty big impact. But stateless changes should be relatively straightforward to do. There's a couple different ways you can approach this. These are typically like, let's see, indexes, functions, stored procedures. These are things that don't have any kind of state behind the scenes associated with them. They're just either kind of some kind of procedural logic or something that's on top of your actual state itself. So one approach I've seen is just a drop and create. So drop the thing first if it exists, and then when you're done, just go ahead and create it all over again. That way, with this drop and create, I can run this script multiple times as I'm testing it out locally, and then when I get to the actual migration script, then it should run successfully. There's better ways to do this these days. If you're running SQL 2016 or later, or SQL Azure, or really Postgres since forever, you have these create or update, or create or alter statements. So in this case, it will create a new stored procedure if it doesn't exist, but if the procedure does exist, then we'll just alter this procedure in place. So these days, hopefully you're running in a later version of the database, and you can use these kind of statements as well. Now, the way the migration tool treats these scripts, Roundhouse, it has scripts that can run only one time. So those are my schema migrations. It says, basically, you can run that one time, and you can never change that file ever again. But these kinds, I can actually run them multiple times. So the way that Roundhouse treats this, it actually will have a special folder, sprox functions indexes, where I have these kinds of files in there. And instead of me having migrations of the stored procedure over time, I actually just define it once in that file, and then I just keep editing the file over and over again. The RedGate tool does a similar kind of thing, where it has migration scripts for DML, but for procedures and functions, you just basically edit those things in place, and it will generate the create or alter statement for you. Now, there are some kind of exotic refactorings that you can do as part of migrating your schema. So we see things like renaming a table. Typically, there's depending on the database, there's a special way to do that kind of operation. So in this case, we're going to use a special store procedure to rename a table in place. So we just use the sp_rename store procedure, rename the person table to student in this case. Now, a lot of times, I can't easily fit migrations into just like one single step. And we especially see this when I start to have lots and lots of data as part of that table. And so for those, you start to see migration splits out into multiple stages or multiple steps. Because I can't easily just accomplish that with like one single go, I have to split that into multiple steps. So one good example is splitting a column. This is like one of the few examples I could actually find. Like usually you just normalize this from the get-go. Just humor me for a second here. Let's say I was dumb enough to put the entire name inside of one column, and I want to migrate that into having those two names as separate single columns as part of the database. Hopefully we've got some easy way to do that based on the text as part of it. But the way we'll do this is first we want to create those new columns as part of that table. So we execute one statement that will add those two new columns for first name and last name. The second part will have some kind of migration step that will migrate the data from the existing column into the new sets of columns. And then finally we'll clean up after ourselves and remove that previous column. Or we may just delete the column altogether. Now, splitting a table is a little bit more challenging. So in this case, we've added more and more columns on top of it that represent additional information. And we get to the point where we're like, oh, this isn't normalized enough, so we actually need to split these out into two different tables. So this is a little bit more challenging than the previous one, where it was just in place, be able to split that one column into two. So in this case, we have to attack it a little bit separately. The first thing we're going to do is create a new schema for that new table that exists over to the side. Then we'll go ahead and migrate the data from the existing table into that new set of tables. And then the last step is then to remove all of those old columns. So it's the same kind of pattern where I create the new schema, migrate the data, and remove the old stuff as I go through. Now, with all of these kinds of changes, you're introducing the possibility that your application is actually broken for a split second. So you saw previously when I did the deployment, I deployed the application in one step, and then the second step was in deploying the database migrations. Well, what happens if the first step succeeds and then the second step fails? What do I do then? Well, some migration utilities have this concept of up migrations and down migrations. But because I'm including both the application change and the SQL scripts inside the same code base to get pushed out at the same time, it's not actually easy to perform a down migration if the application has already been deployed. So in those cases, what I typically handle it is to have a new commit that is going to roll back the previous set of changes to get it back into a good known state. So in that kind of manner, it's only, the term is you only roll forward, you never roll back. I'll have a new commit that fixes the thing that I just broke, and then I can go on from there. But these come all into this overall umbrella of migrations at a much larger scale. So if I can't if making these kinds of changes to my database will just bring it down for a potentially long amount of time, then I can't use those same kind of techniques that I used in much smaller or even much more less user-focused sort of systems. So if the user's not, if I have the ability to bring the system down at a certain point in time, we're just going to go down Friday at midnight where no one's logged in and it's not a big deal, well, we can do that. One of the things I found, though, is that if you're making these kinds of migration scripts against a local database that has no rows in it, things go pretty fast. If you start to make these changes in production databases that have a lot of data in it, then it could take a very, very long time. And one of the first frustrating things I found was that if I'm making a migration of some schema that's going to affect a lot of rows, and it just hits go, I have literally no idea how long it's going to take to complete. There is no progress bar on adding an index to a table with 1 million rows or 1 billion rows. It's just going to start churning, and then you just got to wait and wait until the thing finished. And sometimes doing those kinds of changes prevent anyone else from using the system because it can lock the entire table while it's performing this operation. So ideally, if I'm now finally in production at a large enough scale, I want to enable zero downtime changes. That is, I make changes to my database and application without bringing anything down along the process. But to do so is going to be much more challenging and difficult than our normal migration steps. We actually have to think about the changes we're going to make, figure out the actual impact of those changes, and build out a plan of how we're going to affect those changes in production. So there's a lot of different techniques out there. One of the ones I really liked described was from Stripe, and they described how they do their online migrations at scale. And they built all these tools to help do that sort of thing as well. But the way you have to do it is with a much more deliberate incremental process, where you're not just migrating the schema all at once, but you go through these very small changes, very small steps to be able to get your change out in production. So let's say I want to do that change I had before, which is I have one table with like 5 columns, and I want to normalize that so that it's going to be 2 tables. Well, I can't just roll out that change all at once, because that could be a billion rows that it's affecting all at once. And trying to get that in one single deployment is just going to be too much work. So we can break this down into a much more step-by-step process. The first step we're going to do is to perform a dual writing step. In this case, what we're going to do is modify our application code to, instead of just writing to the initial table, we're going to have it write to both data stores at the same time. So as I write the information for my alias in one table, I'm at the same time going to write that alias in the other table. Now, the challenge with this approach is you have to be very, very sure that you found all the right paths in your application. And for a lot of legacy systems that I see, there's like an untold number of write paths, because it's a legacy system. So it's like anyone can change anything at any time, or they've tried to just stuff everything in store procedures and hope that I figured it out there. But it's really hard to analyze those kinds of paths. So one option I've seen work successfully for us is use the T word, which is a trigger. Be like, every time you write this thing here, just go ahead and write it over there as well. And one of the advantages here is it still participates in the database transaction, so it ensures that if something doesn't get written, then it can roll the transaction back, and both sides of the equation are still going to be okay. Now, this is kind of a precarious middle step, because now I've got 2 sources of truth, so I do want to make sure that I don't have anything except that explicit integration path that's writing to my second database table. And I have to worry about, what about all that existing data? I've got 1 row here, but what if I've got that billion rows of data for all these names and aliases? How do I migrate that information for all the kind of back history going on there? So the write paths only take care of new data. So new writes going in, yes, I can have it go to the other path, but for all that existing data, I have to figure out, what am I going to do with all this? So I need to figure out what is going to be my strategy for getting that data from where it is today to where it needs to be. And honestly, one of the solutions could be just do nothing. Like, you just don't care about the old data, that it's only for new data going forward. Or you can say, I'm going to go ahead and copy all the data from the existing database tables into the new tables. Now, this is probably not something you want to do all at once, because again, if you're trying to do a single update statement from an existing one, like where I'm inserting a billion rows, that could take absolutely forever. So what we often do is try to split that into individual batches. Now, this may take a long time, but what I'm trying not to do is have a transaction that's open for like a week. Instead, if I just do a certain set of records at a time, maybe 1,000 or 10,000, then I'm reducing the transactional load on my destination table. We want to make sure, too, that we don't accidentally overwrite data. So oftentimes, we'll run this a couple times to make sure we didn't miss anything, and that we've got all the right data into the right spot. OK, so now that we've got our write paths figured out, which still could take a long time. Like, this step I've seen take like 3 months to figure out all the places that are being changed and how to get all of them writing over to the correct location. We'll do things like run true-up reports that compare the data in the second table with the first table and see if there's any discrepancies and any places we need to then go fix. Once we've got that in place, though, and we're reasonably sure we've got basically 2 identical sources of truth, then we can update the read paths to point to the new source of truth, which is this new table. So in this case, I'm updating any kind of queries that are going to my existing table, but I'm modifying all the read paths in my application to read from the new set of tables as opposed to the old set of tables. And this can also be done incrementally. I've done this like 1 read at a time, where I changed one path from the old table to the new table, release that into production, run my true-up report, see if there's any discrepancies, and then do the next, the next, the next, the next. The more incremental we can do this migration, the less risk we'll have in the overall migration. So now that once I've got that reasonable certainty that I've fixed all the write paths and fixed all the read paths, now we can update the write paths to only write to the new set of tables. So the application is now wholly dependent on the new set of tables for its information. At this point, I have a few choices. Sometimes what I've done is then reverse the previous arrow, where the new table will have triggers that write back to the old table to ensure that if there's just something out there that's still looking at my old stuff, it won't just completely break. But eventually, I want to sever all those connections to the old information. Then the last piece of the puzzle is to remove the old information from that legacy set of columns or tables. So this is the point where you're just deleting the columns out of the database, and everything should then be using all these new paths. Now we want to make sure we have data integrity checks at each step of the way. So this is often very customized, where I'm running counts and discrepancies and looking at heuristics to see how everything matches up. But if everything looks green and everything's 100% match, then I should be able to make the move to the next step in the process. Now, what about very, very large table migrations? Let's say I'm just making a smaller change to the system that's affecting this overall table. So I'll break this up into individual steps as well. First step will be to create a new table with the new schema. Then I batch fill the new table with all the old information. And then I rename the old table to the new table. So basically, I'm like doing a swap. This is kind of like blue-green deployment for database tables, where I create a new table to the side, fill it with all the information, and then swap it for the old table. And now I've got a new table with all the new information ready to go. There's a lot of different techniques you can use here as well. I've seen people as well create new partitions or file groups for the new table information, so I'm not even affecting at all the existing underlying hardware that the existing database is running on. Very often with things like indexes, can totally screw up the performance of your system as it's trying to build this index of 1 billion rows. So you may want to create that off to the side, and then when the time is ready and it's done, then you go ahead and connect it to the existing database. So these are all the techniques I've used for relational databases. This is one of those things that you don't really know or care about until you hit it in production. And then it's like release night, and oh my God. So I do want to really caution folks, as you're doing these kind of database migrations, do keep in mind what you're actually changing in production to understand what is going to be the potential impact as you do that. And so we'll do dry runs of these migrations as well, where we'll have a prod backup that we run migrations against first, that have an exact replica of what we see in production to get an idea of this one is actually going to take longer than X amount of time, so we need to rethink how we're going to do this migration to ensure that it's going to complete within the SLA that we're trying to affect. But what about NoSQL? What about databases that don't have a schema? And for a lot of the systems that I run that run NoSQL databases, it's very easy to develop these kind of systems locally because I don't have to worry about schema migrations at all, right? I just keep coding and changing the shape of things and coding and changing the shape of things, and everything works. Until you release it in production and make some change that breaks my schema. And so I have this range of emotions that I go through of disbelief, craziness, crying, oh my God, what am I going to do now? And then just banging my head on the table, how could I possibly solve this problem? Because I was promised that there was no SQL, there's no schema. But there is a schema. It's just somewhere else. It's in your code, which is much harder to track down changes to and modifications, and much more difficult to track those changes over time. So the first thing I look at is, one, do I even need to migrate data? So this is not a NoSQL migration strategy. It's not something I typically put into place at the beginning of a project. But I do find that in NoSQL databases, especially document databases, it's really not unlike other kinds of documents that I'm working with, like API documents, the JSON documents I've returned from web APIs, or messages, I stick on some kind of AMQP or RabbitMQ. And it's just still JSON, right? So can I apply the same kinds of techniques I have for those kinds of messages and documents to my document store? We also find that people are typically doing NoSQL in a microservice kind of environment. And so in this case, I've got some kind of like insurance system that I've converted to microservices, in which each step of the overall process for issuing an application for insurance is broken up into its own individual service. And in this case, I've got different databases for different kinds of needs. So if I'm choosing the right database for the job, it's not necessarily always going to be a NoSQL database. So in our case, we had the initial step in the process, which was a sales application. Well, that sales application had data that changed, that had needed to be kept over a long period of time. So the sales database was like Salesforce or something, and they kept up those sales databases for years and years and years. But the middle part of the application, that is much more kind of not as long-running, more short-lived kind of data. So once they perform each of these steps, they don't really need to keep that data anymore. It's like I've done the thing, and then my step is done. I just toss that information out the door. But then I typically have some final step, which is in receiving the results of all these intermediate operations, and now that becomes like the more traditional schema-full kind of database. So if you do need to migrate, there are a few options we have at our disposal. The first is just to migrate on read. That is, when we read the document out of the database, we check to see if it's at some specific version, and then execute some code based on, I need to migrate this from one point to the next. This I found is pretty valuable because I only really care about migrating the data when I need to use it again. And so if I migrate it when I read the information back out, that lets me just more incrementally and on the fly migrate my documents from one point to the next. Sometimes we can't always do that. We need to do it more in bulk. And so we can migrate using a tool. And the tool that I like to use is a tool called Node Migrate. So it is node-based or NPM-based, but it's still very easy to automate. And basically, I write my migrations with JavaScript. And very similar to I had the schema migrations, I'm loading a document out of the database, checking its version, and then performing whatever kind of in-memory change I need to, and then that document is then persisted to the database again. Or I just don't. Do we actually need this kind of migration? So one of the things that we found in our NoSQL databases is those NoSQL databases were really for short-lived data. But then the business was looking at it and saying, like, we want to run reports on MongoDB, which, like, don't do that, by the way. Like, Mongo is not built for reports. Instead, what we wound up doing is creating a migration process in which we separated out transactional, short-lived information from historical information. And the way we would push those changes out is either through messaging, eventing, or triggers, so that as someone made changes to the transactional database, we actually spit out some kind of message to say, someone has done this thing. That would go through an ETL process, and then that would finally go into a data warehouse where the business could actually run reports on it. So if I can get away with just like not doing migrations, that'd be better, right? Like just one less thing for me to do. So it did take some convincing from the business to be able to have this kind of picture where I'm not allowing them to look and report off my existing database, and then having a very specific set of controlled output that they can then put into the data warehouse, which in that point, that is actually versioned and uses migrations. And so for us, we actually just get rid of old data. Like once one of these steps is finished for an overall application, we actually don't care about that data anymore. So we have these cleanup steps that just get rid of old data that says we don't need the underwriting application information from 2 weeks ago because we issued the thing, so just go ahead and delete it. So some parting thoughts here. CI/CD with databases is not only possible, but it is necessary. If we want to be able to have the same kinds of agile delivery with our databases as we do with our code, then we have to institute a very similar kind of process that we have with our code as with our database. It does require a lot more thought and planning. Because databases are stateful, not stateless, I do actually have to think about how I'm going to take that database from one step to the next. Mistakes are going to be a lot more costly, of course. So we want to apply techniques that allow us to very incrementally take our application and database from one step to the next. And if we can make these little bitty baby steps, overall, that allows us to actually go a lot faster. My final recommendation is to learn your DBA's whiskey preference, because you will need to bribe them on these techniques and tools. So anything you can do, like help smooth things over with them, and don't make an enemy of them, because again, their skills are actually much more valuable than yours because they have the data. So do become their friend. So that was CI and CD with databases, or for databases. This application is actually going to be on my GitHub. So if you want to check out a full running example, I'll have it up there. Otherwise, thank you all for coming, and have a great rest of the conference.